Hello, this video is for the IXL activity titled Graph Solutions to Absolute Value Inequalities. Its three-character code is November Echo Niner, and at the time of this recording, this activity can be found in Algebra 1, Section L, and it is activity number 4. Now this activity is very closely related to another one that we done earlier. I have that listed in the lower right-hand corner of the screen here. It was titled Solve Absolute Value Inequalities, and its three-character code was Hotel X-Ray Hotel. If you go back and check out that one, I spend a lot more time talking about the process of solving the absolute value inequalities. I'm going to go ahead and do some more examples of solving absolute value inequalities here, but I'm going to go through it a little bit faster than I did in that previous video for solving absolute value inequalities, because I want to get the solutions and focus more so on graphing the solutions as opposed to putting inequality statements, compound inequality statements of and or like we had done in this activity, solve absolute value inequalities. Remember that if we have an and statement, it results in creating a bar. And if you kind of think about it, the bar here, or a line segment to be exact, and a line segment has two endpoints, and it has a line in between. So it has 3 points: endpoint, line, endpoint. And the word and has 3 letters, A and D. So we take that concept of 3 letters, 3 parts of the line, and we put that all together to come up with the memory device that an and statement creates a line segment. And then an or statement, well, think of oars on a boat, O-A-R, and whenever you have oars on a boat, they point outward. Well, with an or statement, whenever we graph an or statement, it creates 2 arrows that point outward, just like the oars on a boat point outward. So if it is an or statement, the arrow is going to point outward. If it's an and statement, it's going to create a line segment. So let's go ahead and start on this one here. I like to rewrite each of my problems. So C plus 4, absolute value of C plus 4 to be exact, greater than or equal to 2. So let's go ahead and create our positive form of it, C plus 4, greater than or equal to 2, and then our negative form of it. We're going to create that by taking a negative sign and some parentheses, and then whatever's in the absolute value portion of the inequality, we're going to put that inside the parentheses. So let's throw that C plus 4 in there and bring down that greater than or equal to 2. Now let's solve each of these. Let's go ahead and subtract 4 from each side. Those 4's cancel each other, leave me with C. Bring down my sign. 2 minus 4 is negative 2, so I have one solution of C is greater than or equal to negative 2. And on the other one, this negative sign out front means the opposite of everything that's in there, so the positive C is going to become a negative C. The positive 4 is going to become negative 4, and let's bring down that sign. And the 2. Let's go ahead and add 4. What we do to one side, we do to the other. Those 4's cancel each other, leave me with negative C. Bring down my sign, and 2 plus 4 is 6. I'm not quite done because I can't leave this variable of C as a negative. For now, I'm going to go ahead and actually write it out when I write divide by negative 1. And what I do to one side, I do to the other. We want to divide by negative 1 because whenever we do that, this negative 1 is going to cancel that negative sign, and it's going to leave us with a C. We divided by a negative number, so we need to reverse the sign. And 6 divided by negative 1 is negative 6. So basically, you can see that by dividing by negative 1, basically what happens is that you just change the signs of each of your values. The C was negative, it becomes positive. The 6 was positive, it becomes negative. And don't forget to change your sign whenever you multiply or divide both sides of an inequality by a negative number. So what's this going to create for us? Is this an and situation, or is it an or situation? Let's go ahead and graph this. And we're looking at the first one, find negative 2, and we're looking for everything greater than that because C is greater than or equal to negative 2. So here's negative 2 right here and everything greater. So we're going to go this way, put our arrow in there. And then negative 6, and C is less than or equal to negative 6, so we're going to go ahead and put our arrow in over here. Looks definitely is an or situation. And one thing we want to then consider is, do we need open dots or closed dots? Well, both of these have half an equal sign, so it does carry the equality concept. So we're going to use a closed dot to symbolize that it could be -6 or it could be -2. Moving along to our next example, let's go ahead and do a rewrite here. We have t minus 5, and to close that off with the absolute value sign is less than 4. So let's go ahead and create a positive form of it, t minus 5, and let's create a negative form of it, t minus 5, and bring down that sign and the 4. Let's add 5 to each side over here on our positive form of the inequality. Those cancel each other, leaving us with t, and 4 plus 5 is 9. So my first solution is t is less than 9. Negative sign makes everything on the inside the opposite, so positive t becomes negative t. Negative 5 becomes positive 5. And bring down our sign in the 4. Now let's go ahead and subtract 5. What we do to one side, we do to the other. Those 5's cancel each other, leave me with negative t. Bring down my sign, and 4 minus 5 is negative 1. Now I'm going to divide both sides by negative because I cannot leave the variable of t as a negative value. I need it to be positive. And so if I'm going to go ahead and got ahead of myself there, let's go ahead and make this a positive 1. So it just changed the sign of each of them. And don't forget to go ahead and change that sign. So there's our other solution. T is greater than 1. So let's go ahead and graph this. Change our color there, grab a line, and let's consider t is less than 9. So we're going to find 9 on the number line and do everything less than. So that's everything going this way to the left of 9. Everything to the left of a number is less than that number. And then t is greater than 1. So let's find 1, and t is going to be greater than 1. So we'd fill that in. Now I've intentionally put one line above the number line and the other one below the number line because the space in between I've left open because this is where our solution is actually going to go. If we have two arrows pointing outward and there's some overlap, we don't actually have an or situation, we have an and situation. So we need a bar, right? Endpoint, an endpoint, and then a line segment in between. Let's go ahead and talk about our endpoints. It does not have half an equal sign, so we want open endpoints. So we'll go ahead and leave these open at 1 and also 9. And then we want the bar in between those two there, the line segment, you might say, and that's not, I don't have a hold of a line. There we go. That's what I want right there. So we'll put that on there, and you'll see that once we go ahead and pull this line away, I'm gonna try this, that might be tricky. There we go. Pull that away there. And let's move this one up there. Outstanding. Good deal. I can see now, notice the line segment. It represents the area that overlap between the two solutions. I guess I could try to get tricky there and move all them pieces. Okay. I didn't think I didn't think about the arrow coming apart. So we move the arrow down. Outstanding. So voila. So there's our solution graphed here. It's an and statement. It creates a line segment, has two endpoints and a line. Looking at the next one, they're going to get a little more complicated. I intentionally tried to get let the complexity of them increase. -6 and less than equal to 9. So let's go ahead and write it without the negative sign in front of it out there. That is to say the negative sign with the parentheses. And we have 9, and then negative sign, parentheses, -3w minus 6, and all this is supposed to be less than or equal to 9. Let's work this one over here. Before we can deal with that -3, we got to get rid of that -6. So let's add 6 to each side. This is going to work out real nice because we're going to end up with, what, 15 over there, right? We see that -3 that we're going to have to deal with. -3w. Now let's go ahead and divide by -3. We do to one side, we do to the other. Those cancel each other. And we did divide by negative, so there we go. Need to change that sign. We divided by negative, leaves us with just w on the left, and 15 divided by -3 is going to be -5. So W is greater than or equal to -5. Over here, the negative sign up front of the parentheses is going to change the signs there. So -3W becomes +3W, and -6 becomes +6. Let's bring down our sign in the 9. Let's go ahead and subtract 6 to get rid of the -6, or the +6, and those will cancel each other, and we get 3W. Bring down our sign. 9 minus 6 is 3. Well, this works out real nice. Divide by 3, right? And then we're going to go ahead and cancel those. We have W less than, equal to, and 3 over 3 equals 1. So there's our two solutions there. Let's go ahead and graph them, because that's what this particular activity is all about. It's about solving them and graphing them, but I want to do enough examples that we have a little bit of review on solving them. So we're looking for W is greater than or equal to -5. And actually, let's do this. Let's put our endpoints on first. We're looking for -5, and it has half an equal sign, so it needs to be solid. So let's go ahead and realize that we're going to have a solid dot here. And then on the other one, W is less than or equal to 1. So we're looking for 1 on the number line. So we'll put that in there, solid dot there. Now let's go ahead and put in our arrows. So everything greater than or equal to -5, that would be everything going greater than or equal to. So going this way, right? Oh, get kind of squirrely with the arrow there. And then everything less than or equal to +1. So we would have all of this here. So we see we have some overlap. So it's right in between is where our solution would be. So we end up with that line segment that's on the line there is our solution. Moving along to the next one. Let's do our rewrite. We've got, change the color there, 6 times the absolute value of V minus 65. Numbers getting a little bigger, but I think we'll be okay. Is greater than or equal to 60. So let's go ahead and divide by 6. We want to get the absolute, oh, I guess I should review a little bit. We need to get the absolute value isolated by itself on one side. So if I had 6 times x, I'd just divide by 6, and that would leave me with just x, right? So dividing by 6 here, what I do to one side, I do to the other. Those 6's cancel each other. Indeed, it leaves me with just the absolute value portion of v minus 65. We have to do this before we can split it into the positive form of the question and the negative form of the question, or the inequality. I guess it's a question, but 60 divided by 6 is 10. So now we can go ahead and split that apart. V minus 65, our positive version of it, and then the negative version of it. V minus 65. And that's greater than or equal to 10. So let's go ahead and add 65 to get rid of the negative 65. What we do to one side, we do to the other. Those cancel each other, will leave me with V and 75. And we want to make sure that the number is on the number line. If we come up with a solution and we don't see it on the number line, we probably did something wrong. But I see 75 on the number line up there, so I'm good to go. Negative V becomes positive V, or positive V becomes negative V. Negative 65 becomes a positive 65. Bring down our sign there. And then we're going to go ahead and subtract 65 from each side. And those will cancel each other, and that'll give me a negative V. And 10 minus 65 is what, negative 55? Well, let's go ahead and grab that and move that up there up top so we got a little more room. We'll put it over here. And let's continue on. I'm going to divide by -1, so that's going to give me a positive V, but I did divide by negative, so I need to switch the sign. Negative 55 would become positive 55. And so there's the other solution. 55 is indeed on there. So let's go ahead and graph those dots first. Open dot or closed dot has half an equal sign, so we need open dot, so it's included. We're looking for 75. There we go there, closed dot, and 55 right there. Let's determine, is it an and or an or situation? And let's see, everything greater than or equal to 75, so that's everything to the right of 75. Looks like it's going to be an or situation. And indeed, everything less than 55, so it's everything going this way. So we're good to go. Let's look at the next one. Doing a rewrite here. So we have -6 is greater than or equal to z, the absolute value of z minus 6, and all this minus 9. Now, I like my absolute value and my variables, I like them on the left side of the inequality. So I'm going to rewrite this, and I'm going to have absolute value of z minus 6 minus 9. That's everything that's on the right side of the inequality. But by doing so, if I'm going to flip them around, if I'm going to move things from one side to the other, I also need to switch the sign and throw that negative 6 over here. So I can do a rewrite, and let's kind of center that up a little bit. We'll put that there. There we go. All I did is just flip the sides, but I had to change the sign. So let's go ahead and add 9 to each side. What I do to one side, I do to the other. Those will cancel each other. And remember, we're doing this because we have to first isolate the absolute value portion of the inequality on one side before we can split it apart into a positive form and a negative form. Negative 6 plus 9 is a positive 3. So all this here was just moving things around and isolating that. So let's move all that over here, and we'll move our problem up here. Let's go ahead and split this into a positive form. Z minus 6 less than 3. And this one over here, the opposite of Z minus 6. And we'll make that less than or equal to 3. Let's go ahead and add 6. We do to one side, we do to the other. The 6's cancel each other to leave me with Z. And less than or equal to, and 3 plus 6 is 9. And I do see a 9 up there on the number line, so must be good to go. Positive Z becomes negative Z. Negative 6 becomes positive 6. And bring down the less than or equal to 3. Let's go ahead and subtract 6 from each side. Those cancel each other, leave me with negative Z. Bring down my sign. And 3 minus 6 is negative 3. Divide both sides by negative 1. That's going to make the signs change. And it's also going to flip my sign. So my other solution is here. So I have Z is less than or equal to 9, and Z is greater than or equal to 3. So let's go ahead and plot each of those points. 9 and 3. There's 9. Here's 3. And we need solid ones because they could be equal to 3 or 9 because we have half of an equal sign there. And then everything less than 9. So we'll grab our line here. So we're talking about everything less than 9 going this way. And then everything greater than or equal to 3. And that would be everything going this way. So we have an overlap situation. So that is an AND situation. So we connect that together to create our line segment. On the next one, we have the absolute value of 5V plus 50. And we should subtract 3. And all this is going to be greater than or equal to 97. Not 99, 97. So let's go ahead and isolate the absolute value portion of it because we can't split it apart until we have isolated the absolute value. So we got a negative 3 that's tacked on there, so we're going to get rid of that with a positive 3. And this will work out real nice because I think we're going to end up with 100, and that'll come in handy in a little bit. So absolute value 5V plus 50 is on the left. Bring down the sign, and 97 plus 3 is 100. Let's grab the work that we did to isolate the absolute value portion of it, and then we'll grab our inequality now that is nothing but the absolute value by itself on one side. Isolate it. To get by itself is to isolate it. And let's create the positive version of it. 5V plus 50 greater than equal to 100. And then the opposite form of it. 5V plus 50 and greater than or equal to 100. Let's go ahead and subtract 50 from each side. We do to one side, we do to the other. Those 50s cancel, leave me with 5V. Bring down my sign, and 100 minus 50 is 50. Now let's go ahead and divide both sides by 5, and 50 divided by 5 would be 10. So we'd end up with V is greater than or equal to 10. Let's apply that negative to everything inside there, negative 5V, and the positive 50 becomes a negative 50, less than, equal to 100. Let's go ahead and add 50 to each side, plus 50. So those would cancel each other, leave it negative 5v. Bring down my sign, and that would be 150. Next, I need to divide both sides by negative 5. Well, that's going to leave me with v, but I divide it by a negative, so the sign's going to switch. 150 divided by negative 5, well, positive divided by negative is going to be negative, and 150 divided by 5 should be 30, right? 15 divided by 5 is 3, so 150 divided by 5 would be 30. So here's our other solution, our numbers on the number line. I see negative 30 up there. I see positive 10, so it must be good to go. They do have half an equal sign, so I need a solid dot at both 10, and I need a solid dot at negative 30. Is it an and or an or situation? So grab this here. Everything greater than 10 looks like it's going to be an or situation. So there we go. And everything less than or equal to negative 30 would be this way. And that would be our solution for this inequality. Okay, let's go on to our next one here. And we have, oh, I want to go back to white. There we go. Negative 2 times the absolute value of 5r minus 75. I'm supposed to add 7 to that, and this is all supposed to be less than or equal to negative 43. Before we can deal with this negative 2 over here, we have to first deal with the positive 7, so let's subtract 7 from each side. Those will cancel each other, leave me with negative 2 times absolute value of 5r minus 75 less than or equal to, and negative 43, not plus 70. That would seem a little off, so it's going to be negative 50. Let's go ahead and divide everything by negative 2, both sides, because we want these negatives to cancel each other, leaving us with the absolute value of 5r minus 75. And we just divided by a negative number, so we need to flip the sign. Negative divided by negative is positive. 50 divided by 2 is 25. So after isolating it, we end up with the absolute value of 5r. Shrink that down a little bit. There we go. Absolute value of 5r minus 75 is greater than or equal to 25. Let's go ahead and create a positive form of it. 5r minus 75 greater than equal to 25, and then a negative form of it. 5r minus 75 greater than equal to 25. Let's add 75 to each side. Those cancel each other, leaving me 5r on the left. 25 plus 75 is 100. Let's divide both sides by 5. We end up with just r on the left. And 100 divided by 5 is 20. So r is greater than or equal to 20. And yep, 20 is on the number line up there. Positive 5r becomes negative 5r. Negative 75 becomes positive 75. Greater than equal to 25. Let's go ahead and subtract 75. Go back arrow. Let's subtract 75 from each side. And those will cancel each other, leaving it negative 5r. And 25 minus 75 is going to be negative 50. Let's divide both sides by the negative 5. That's going to leave me with r. I did divide by negative, so flip the sign. And negative divided by negative is positive. 50 divided by 5 is 10. Our other solution should be r is less than or equal to 10. And indeed 10's up there. Let's plot those 2 points. 20, and we do want a solid dot. I guess all of them. I should have found some that had open dots, right? But this is a solid dot and also positive 10. So this is either going to be arrows going both ways or a really, really short line segment. Everything greater than 20 looks like an or situation, right? Everything greater than or equal to positive 20, and anything less than or equal to positive 10. So fill that in, and there's our solution here. I think we have one more. I know you're like, one more, holy cow. Opposite of absolute value of 800, I'm trying to write with a line. Try to get rid of that. There we go. Go back to pencil. Yeah, subtraction signs and absolute value bars are okay to write with a line. It's kind of hard to write an 8 with a line, that's for sure. Less than, equal to, negative 800. I need to get rid of the negative sign out here. Right now, the absolute value portion is not by itself. So I'm going to divide by negative 1. And what I do to one side, I do to the other. Now, since I am dividing by negative, the sign is going to change. So I'm going to flip that now before I ever write anything else so I don't forget. That negative is canceled by the negative 1. And what do I have left? Well, I have the absolute value of 800 minus 4v. And then this is just going to be positive 800, right? So now I have isolated the absolute value portion all by itself on one side. Let's go ahead and slide that work over here, and we'll move this up here. Now that we have the absolute value isolated on one side, we'll go ahead and do the positive and the negative form of it. So 800 minus 4v less than or equal to 800. And I'm like, that's a lot of 800s. I'm looking over to make sure. Yep, there's two of them. So absolute opposite of the absolute value of 800 minus 4v and greater than equal to 800. Let's do the positive form of it first. Let's go ahead and subtract 800 from each side. Ooh, 0 maybe? We're going to end up with those cancel each other, bring down a negative 4v. And 800 minus 800 is going to be 0. Yep, indeed it's going to be v is less than, because look, we need to change the sign, right? Divide by negative 4. Those cancel each other, but we did divide by a negative. Leaves me with just v, and 0 divided by anything is just 0. So this is our first solution here. And on the next one, I'm going to go with maybe, nope, 1600 is not on there. So well, I'm going to have to divide by 4. 400 maybe. I'm just kind of guessing in my head. Negative 800. Positive 800 becomes negative 800. Negative 4v becomes positive 4v. And bring down all the rest of this. We're going to go ahead and add 800 to each side. And those will cancel each other, leaving me with positive 4v. That's 1600. Yeah, I think we're going to be, what, 400 it's on there? Yep, 400 is on there. Good. So I'm going to divide this by 4 and this by 4. Those cancel, leave me with v. And 16 divided by 4 is 4. And I still have my two zeros. So indeed it is 400. So let's go ahead and plot those points. Again, they have half an equal sign. I'm sorry, every one of my examples, none of them, hardly any of them, were just the open dots of greater thans or less thans. But we have the equal concept here, so let's go ahead and plot that out. Find one point of 0, solid dot, and the other one 400, solid dot, so it includes 400. And then and situation or situation, we're looking for v is less than 0, so everything less is to the left. Definitely looks like an or situation. And then everything greater than or equal to 400. So this one goes out over here, that away. All right, so that is my final example for all of my questions for graph solutions to absolute value inequalities. Now, go level up your learning.